And then we see in all of these examples, here is our parent graph, here is our key one, and they've got one point labeled, which is 16, 4. This is our point. And we're going to look at what happens to that point with each of these transformations. And we notice that in the blue graph, the green graph, the canary graph, and the purple graph, pink, violet, not sure, whatever color that is, we're going to see what happens to that point, and we're going to notice in each one of these ones that it affects only the y-coordinate. So on our square root graph, one of the points on our square root graph is 16, 4. You could find that out by plugging in 16 for x and evaluating it. You would get y equals 4. What we're going to do for each of these graphs, we're going to show what changes. So if I took this 16, 4, which was on my original graph, with that 3 in front, what's going to change is you're going to multiply your y value by 3. And this is the kind of work you're going to show with your transformations. You're going to start with your original point, 16, 4. You're going to draw an arrow to show that there's been a transformation to that point. And you're going to write above it what's happening to that point. Y is going to get multiplied by 3. And so we're going to end up with the point 16, 12. And that's right there on your graph already labeled. On the green one, if we started with our original point, 16, 4, what do you think that 2 in front's going to do? Y by 2. So multiply our y value by 2, we get 16, 8. When we go to our orange or canary or whatever color graph, wow. Attempt that. I don't know. Oh, didn't work. No, still not working. Try this one. There we go. Beautiful color. We're going to multiply our y by 1/2. So again, our x stays the same, and if we take half of 4, we would get 16, 2, and sure enough, that point shows up there. And finally, on our purple graph, we have 16, 4. Here, with the 1/4, it'd be y by 1/4. Again, the x value doesn't change, but when I multiply my y-coordinate by 1/4, I get 16, 1. And you can see the effects that the graph is either being stretched away from the x-axis in the first couple, in the blue and the green one, and compressed in the other ones. So we use the word stretch whenever that value is bigger than 1, and we use the word compress whenever it is less than 1. The proper language, and I'll just do it for the blue one here. If we take this blue one and we wanted to say what the transformation was, we would say the graph of y equals the square root of x has been stretched vertically by a factor of 3. So that would be how you would describe it. The grade 12 course is big on explaining. They have a big portion of your exam that says explain, and you have to use words, and you have to write sentences, and you have to justify it. So this would be explain the transformation that takes place. You would say the graph of y equals square root of x has been stretched vertically by a factor of 3. So there's our first set. When there's a value out in front, outside affects the y coordinates. On our next one here, you see that each of those numbers are inside. Numbers that are inside are going to affect the x-coordinate. So again, here in red is our parent graph. It's one of the ones on our sheet from Friday. You need to know quickly what it looks like and what are some points on there. The point that they have labeled this time on this graph, and they're just using one point to give an example, is we have the point 4, 2. And that was one of the key points I said you need to know 0, 0, 1, 1, 4, 2. Those are the normal ones that you would know first, the first three. So we have 4, 2 as our point. Now, just like transformations that move things left and right, translations, remember how when it was with the x, it was the opposite? That if you had x plus 2 inside the square root, that would move it 2 to the left, not 2 to the right. It was sort of the opposite. The same thing happens with horizontal stretches and compressions. Things happen the opposite way. So when we have a 4 inside, we take our original point, which was 4, 2. We say, what is our transformation? And instead of multiplying x by 4, we multiply it by the reciprocal, x by 1/4. And if we do that, we get the point 1, 2. So this is a horizontal compression by a factor of 1/4. In the green graph, same thing. We have a value bigger than 1. Our original point 4, 2, now x would be multiplied by 1/2. And this is the hard part in this unit, is just remembering what's the opposite, what acts the same way. The y-coordinate doesn't change, but the x-coordinate gets multiplied by 1/2. And now that we have a 1/2 inside, if you do the reciprocal, which means just flip the fraction, that'll be 2 over 1. You'd multiply your x-coordinate by 2. And that would change our point to 8, 2. And finally, with the 1/4, our original point of 4, 2, the transformation, your x value would get multiplied by 4. And you would get 16, 2. And the nice thing about the graphs here is they show those points on your graph so you can see how it changes. You may want to color code these later so that you can see it when you're reviewing your notes. But there you get the idea. So whenever it's inside your original function, and if our original function here is the square root of x, then it's going to move and affect the x-coordinates. And finally, the last graph looks at what happens when it does both. Again, the red is our original graph. They're using 4, 2 as a point. And when you have two things happening, you have a choice to make two sets of arrows. But since one affects the x and one affects the y, it's going to be easiest if you, again, start with your original point, draw your transformation, and right above it, what's that 4 going to do? Y. And it's going to do, multiply the y by 4. And then inside is the 2, and that's going to affect the x by 1/2. Okay? Now, when you're showing me your work and doing these questions and showing your transformations this way, it's important to write above what you're doing, because if you mix things up, if this is a 2-mark question, I'm doing 1 mark for the x-coordinate, 1 mark for the y-coordinate. If you mix things up and show me no work, then I'll give you 0. If you mix things up and I can see, oh, you had the right idea, you just forgot to multiply by the reciprocal, then you can sometimes get some work for showing your work. Some marks for showing your work. So here we go, 4, 2. If I multiply my x by 1/2, my x-coordinate is going to become 2. And if I multiply my y by 4, my y-coordinate is going to become 8. And you can see that point right here on our graph, 2, 8. Okay, I'm going to give you minute head start to do the points for the last three and see how you do.